Okay, welcome everybody again. So in this tutorial we will connect the simulation to ROS. First, let's check if the packages are correct installed. You should find a ROS TCP connector and URLDF importer. If both of them, if neither of them is there, then you need to install it before continuing. Now, let's go to the robotics menu in the top bar and click to generate ROS messages. What we'll be doing here is to create the stubs to connect our simulator with the ROS. Let's go to the folder of the code you downloaded from GitHub, from the project. You should find there two folders, ROS and Docker. You downloaded this in the first tutorial. Select the ROS one and give choose. Then it will open all those messages. What we need to do is to click and transform those messages into files into Unity. We will do this by selecting first move it messages, robotic trajectory. This one, and you can click to build. I already built it, so for my PC is rebuild, but for you should be building. And then you can go up and let's go in the next message. Till we find the Nirio Move It folder. We have here two messages to build. The joints and the trajectories, and the other one that we have to build is just below, the one from server. All these things will allow to transmit information from the Unity simulator to our program. Exactly, also rebuild for me, but for you should be built the first time. Now that we finish it, we can close this tab and check if the messages are correctly compiled. For this, we'll go into Asset, ROS Messages, and you should find a C# code file for every one of the messages that we built. The ROS trajectories, and finally the messages from the Nirio robot and the server. If this is present in your folder, then you did this step correctly. Otherwise, please contact me, because without this we won't be able to continue. Okay, so now that this step is done, we can proceed to the next part of this tutorial, which is actually to use those messages to send something to the ROS container. We will create a new empty game object called a publisher, and we will add to it one script that will actually do all the parsing and send the information. The script is called the source destination publisher. So you can go into add component as I did before, and you can go here exactly. You can see that there are three possible targets: Nirio 1, target, and target placement. What we need to do is to drag and drop the corresponding object from the hierarchy inspector to the slot. We'll start with Nirio 1 in this moment. Now we can continue to the ROS connection. First, we'll need to see if the ROS connection is active. We'll also go to robotic, ROS settings, and we'll remember to add this IP address both into the ROS IP address and the override Unity IP address. This is necessary because we are running both the simulator and the ROS node in the same PC. Otherwise, you could use your network to discover it. Okay, now that this is done, we can proceed creating some small object that we need in order to complete this tutorial. The first one is the button. Button, it is an interaction, something with which you can interact into your game scene. So you will see that it will automatically create a canvas. A canvas is a 2D screen where you can draw. So the end of the objective of this is to create in the game scene this button that you can see here. So whenever you go to play, you can interact with this button to run the code and publish the information from the robots to the ROS node. in order to assign to it some function, we need to first drag and drop our publisher on the method click. What will happen here, once we press click in the button, this function will be called. In order to do this, we create in the onClick method a new object like this. We drag publisher as an object, and we'll select as a function the publish method of the source destination publisher. Exactly. Now, once with this part complete, we are almost there. We miss exactly, we need to change the text, because now it's just button. We can put publish or whatever you want. The text that you change here will appear once you run your screen. Now it's the moment to finish, to add the other two small objects that are the target and the target placement. Those are simply information for Unity to send back to the robot controller to tell it where do we want to go. We will also add this to the publisher as we did before, no? Just drag and dropping the target object to the target slot into the source destination publisher script, and doing the same also for the target placement. Now we can open our terminal and run the Docker container that you created before. Once inside the Docker container, use ROS launch to launch the tutorial. You might have an error like I had in this situation, which is due because the script server endpoint is not executable. It was a mistake while preparing the container. You can fix it with this command chmod u+x and the name of the file. This will set the correct execution bit on the script and will allow you to proceed in case you have this error. I'm not sure, it just happened to me while I was doing the video. Okay, now you can repeat and you should see that now the server has started correctly. This means that ROS is running correctly and waiting for input. If you start play from Unity, then what you did before should connect the simulator with the ROS node. You see here Unity handshake received, which means that everything went well and you are actually connected and everything is good. Great work. Now we can check whether what happened if we publish. If we did correctly, we should see some information sent to the node. This is actually the case. As you can see, the node in the Docker container receives the information sent by the simulator. It gives you the position of the joints and then some coordinate transform, which will be used for you to control the robot. So now what you can do is, if you press play again and then you go move the robot by yourself, just maybe do you remember moving some of the joint manually with the arrows pane? You should be able to, once you do publish again, to see the new coordinates of the join sent back to the ROS container. Let's try if it works. And this is exactly the case. As you can see, we received a new message with some coordinates for the joints that now are not 0 anymore because we moved the robot from the correct position.